simple linear regression. In this module, we will extend our statistical methods to dealing with two continuous variables simultaneously. We do two types of study here. One is the study of association of two variables, which is non-directional in nature, and the study of two variables where one variable is explaining the other variable, which is simple linear regression. The study of association is fairly simple and straightforward. We extend the concept of variance of a single variable to a general two variable covariance. The covariance measures the degree of association, but it is dependent on the values involved in the covariance calculation. So we standardize this covariance to a -1 to +1 scale to come up with a scale which is a lot more easier for us to interpret, and that scale is called as correlation. For the explanatory models, we study simple linear regression. Simple linear regression essentially makes certain assumptions that the association between two variables are linear in nature, and for that we conduct a series of statistical tests, and the statistical methods are applied to determine the explanatory power of one variable to explain the other variable. So we do a bunch of hypothesis tests in simple linear regression to assess the quality of the model, which involves hypothesis testing of the correlation, the degree of association. Without correlation being valid, there is no point in building the model for explanation. Once the mathematical function is determined for the linear function, we do the hypothesis testing of the coefficients called the regression coefficients or the betas, and then we do the hypothesis testing of the overall quality of explanation by doing ANOVA on coefficient of determination, which is also called as R square.